Hello to one and all who are watching this video. Now we are going to solve a problem which is from engineering thermodynamics subject unit 2. This problem is the combination of heat pump and heat engine. So first, whenever you are going to solve a problem, you have to read the question and understand the given data first, and you have to draw the diagram in case if it is necessary. In this problem you have to read the question and draw the respective diagram first. So now first of all you have to understand what is given in the question and you have to draw the diagram. Now what is given? A heat pump working in the Carnot cycle takes in heat from a reservoir at 5 degrees Celsius and delivers heat to a reservoir at 60 degrees Celsius. A heat engine is driven by a source at 840 degrees centigrade and rejects heat to a reservoir at 60 degrees centigrade. The reversible heat engine, in addition to drive the heat pump, also drives a machine that absorbs 30 kilowatt. If the heat pump extracts 17 kilojoule per second from the 5 degrees centigrade reservoir, determine the rate of heat supply from the 840 degrees Celsius source, the rate of heat rejection to the 60 degrees centigrade sink. So first of all, here they have given heat pump as well as the heat engine. First you have to draw the diagram of heat pump and heat engine. So whenever you are going to draw a diagram for the heat engine and heat pump, you have to draw the heat engine on your left hand side. So heat engine should be drawn like with this symbol by using a drawing a circle like this, and you have to mention heat HE to mention it is heat engine, and after that you have to write the you have to draw the circle for heat pump. You have to mention here as HP, which says that it is heat pump. And now what is given in the question is you have to read it and understand it. Here first data which is given in the question is the Carnot, the heat here, the heat pump is working on the principle of Carnot cycle and it is takes in heat from a reservoir. You have to draw the reservoir like this box, this like this rectangular box. You have to mention the reservoir. Here the reservoir temperature is 5 degree centigrade. So if you convert this degree centigrade, you have to degree centigrade to Kelvin, then you have to add 273 with the degree centigrade, whatever it is given. Here it is given as 5, so you have to add 5 plus 273 in order to convert this degree centigrade into Kelvin. So it will be 278 Kelvin. So you can here mention it as 278 Kelvin directly. Instead of writing 5 degrees centigrade, you can mention it as 278 Kelvin. Here what he has mentioned is the heat pump takes in heat from this 5 degree reservoir and delivers heat to a reservoir at 60 degrees centigrade. Here this heat pump is delivering heat to another reservoir which has a temperature of 60 degrees centigrade. The 60 degree centigrade means you have to change it to Kelvin. For that you have to add 273. So it will be 333 Kelvin. So you can mention here as 333 Kelvin. And now what is given? So you can hear this is for heat pump. The heat input can be mentioned here. The temperature input for heat pump can be mentioned as T4 and temperature delivered from heat pump can be mentioned as T3. And now what is given in your question again? A heat engine is driven by a source at 840 degree centigrade. That means here there is another reservoir with the temperature of 840 degree centigrade which delivers heat to the heat engine. So you have to write a reservoir of 840 degree centigrade. So 840, if you want to convert this degree centigrade to Kelvin, for that you have to add 273 as I said earlier. So now it will be 1113 Kelvin. So you can here mention it as 1113 Kelvin. Again, what is given here? The heat engine again rejects heat to a reservoir at 60 degree centigrade. So now here the heat is again rejected to another reservoir. The temperature of that reservoir is again 60 degree centigrade. 60 degree centigrade, that is equal to 333 Kelvin. Here you can see that the temperature of this one is T1. The input for heat engine temperature input will be T1, and the temperature output from heat engine can be mentioned as T2. Here you can see that the temperature of T2 and temperature of T3 is same. Therefore, T2 is equal to T3. Here, and what is given again in the question is the reversible heat engine, in addition to drive the heat pump, also drives a machine that absorbs 30 kilowatt. Here the work output from the heat engine, that is W1 and W2, the overall heat, the combination of work W1 and W2, that is called W3, that is given here as 30 kilowatt, which is given in the question. Now what is given in the question? If the heat pump extracts 17 kilojoule per second from the 5 degree reservoir, here from this 5 degree reservoir, the heat pump extracts a heat transfer, that is Q4, that is given here in the question is 17 kilojoule per second. So these are the data which is given in your question, and he is asking you to find out the rate of heat supply from the 840 degree centigrade. That means he is asking you to find out the Q1, and he is again asking you to find out the rate of heat rejection to the 60 degree centigrade. That means he is asking you to find out the heat rejection such as Q2 plus Q3. Now we have drawn the diagram based on the data which was given in the question. Now you have to start write the given data. So now the given data, what is the given data which is given in your question? From the diagram you can easily find out the given data. T1 is equal to 1113 Kelvin, T2 is equal to 333 Kelvin, and T3 is equal to 333 Kelvin, and T4 is equal to 278 Kelvin, and Q4 is equal to 17 kilojoule per second, and work done is equal to 50 kilowatt. So these are the data, given data which is given in your question, and also he is asking you to find out Q1, and also you have to find out Q2 plus Q3. So given data here is T1, that is equal to 113 Kelvin, T2 that is equal to 333 Kelvin. Here I am writing the Kelvin value directly instead of writing here as degree Celsius, because I have already told you how to convert degree Celsius into Kelvin. Now the temperature T4 is equal to 278 Kelvin, T3 is equal to 333 Kelvin again, and Q4 that is equal to 17 kilojoule per second, that is equal to 17 kilowatt. Now the work done W3 is equal to 13 kilowatt. So these are the given data which is given in your question. Now what you have to find out, what you have to find Q1. First one is heat supply Q1 and the combination of heat rejection, what are the heat Q2, and that means Q2 plus, here this Q2 plus Q3. This is what you are going to find out. First you are going to find out Q1 alone, and secondly you are going to find out Q2 plus Q3, not Q2 and Q3 alone. For that you have to find out Q2. You are going to find out here the combined value of Q2 and Q3. So now we can, the formulae used here in this problem is very important. You have to know what are the formulas that is you are going to use to find out the values. Here the first formula is COP of heat pump for Carnot cycle. That is T3 divided by T3 minus T4. So this is the first formula. You have to memorize it. And second formula, work done to W2 is equal to Q3 minus Q4. And third formula is work done W1 is equal to W2 plus W3. And fourth formula, maximum efficiency of heat engine. HE means heat engine. That is T1 minus T2 divided by T1. Here the efficiency, maximum efficiency of heat engine can also be written as W1 by Q1. Therefore it can be rewritten as Q1 is equal to W1, because the Q1 will be go here and H1 will be come here. The efficiency max will be come here and the Q1 will go here. And the sixth formula is W1 is equal to Q1 minus Q2. So here with this formula you can find the value of Q2, that is equal to W1 Q minus W1, Q1 minus W1. Again, the seventh formula is net heat transfer. To the 60 degrees Celsius reservoir. Which is nothing but the Q2 plus Q3. That is equal to what this is what we are going to find out. So we are going to use almost 6 formulas, and 7th is to find out the direct answer of second one. So now we can go to the solution. First we can use the first formula, that is nothing but the Carnot coefficient of performance of heat pump. COP means coefficient of performance of HP, that means heat pump. So now we can directly write the values from the given data, because the T3 value is given in the given data, which is 333. Here 333 minus T4 value is given as 278. So if you put this value in calculator, then you can find the value of COP of heat pump, that is equal to 6.055. So if you put this value in calculator, you can find out the CO coefficient of performance of heat pump, that is equal to 6.055. And once you find out that, you can easily find out the Q3 value. To find out the Q3 value, you can use the same formula of COP of HP, that is equal to, instead of T3 you can put Q3 divided by T3, you can mention Q3, and T4 you can mention Q4. So now you can directly put the values which is given in the given data here. This is you are going to find out here the COP value which is find here. What we found out is 6.055, and Q3 value we have to find out, and Q4 value which is given in your question is 17 kilowatt. So here we can easily find out the Q3 value. So if you put this value in calculator, for example, if you have to write this as Q3 is equal to 6.055 into Q3 minus 17. You can here multiply it with this value. Now Q3 is equal to 6.055 into Q3 minus 17 into 6.055. Now you are taking this value and writing this, because this value is can be multiplied with both the values which is given in the bracket. So you have multiplied it the two values which is given in the bracket. Now here the Q3, this value will be, if this value come this side, then it will be minus 6.055 Q3, that is equal to minus and this value, multiplication of this value 6.055. Now here what it will come, minus, it is, if there is nothing given then it will be considered as 1. So 1 minus 6.055, that is minus 5.055 Q3, that is equal to minus into this value 7 into 6.055. Now this minus and minus can be written, will be cancelled, and it will be, you can consider it as plus. I think you know very well, this is basic mathematics. Now the Q3 value will be 7 into 6.055 divided by 5.055. Now if you put this value in calculator, then you can easily find out the Q3 value, which is 20.36 kilowatt. The unit for this is kilowatt, for Q3 is kilowatt. So we have find out Q3. Now we can use our second formula, which is which is W2, that is equal to Q3 minus Q4. Here the value of Q3 is equal to 20.36 and the value of Q4 is 17. So by subtracting this value, we can easily find out the W2, which is 3.36 kilowatt. And after that, the formula which we are going to use is W1, that is equal to W2 plus W3. So we know the value of W2, just we found out, which is 3.36, and we know the value of W3, which is 30, which is given in your question itself. Now the value will, W1 value will be 33.36 kilowatt. If you add this value, you can find the W1 is equal to 33.36 kilowatt. Unit for W1 is kilowatt. And now you can use the fourth formula, which is efficiency, maximum efficiency of the heat engine, that is equal to T1 minus T2 divided by T1, that is equal to, we know the value of T1 1113 minus T2, that is 333, and we know the value of T1 1113. So if you put this values in calculator, we can find out the maximum efficiency value, that is 0.7008. and whenever the value comes for in terms of point, the efficiency value always comes in point something, and you have to, for efficiency, you have to multiply the values which is come after this, after solving this on calculator. We have to multiply this answer with 100. Whatever the value you are getting, you have to multiply it with 100 to find out the value of efficiency in terms of percentage. If you are converting this value into percentage, then you have to multiply it with 100. Now the maximum efficiency of the heat engine, that will be 70.08%. So now again we are going to use the fifth formula, that is maximum efficiency is equal to W1 by Q1, So the W1 value is 33.36 and the Q1 value is, sorry, the Q1 value is that Q1 value we don't know. So here we know the value of maximum efficiency, so put that value here, that is 70. Here you should not mention, you should not put the value of percentage, you have to put the value of this one, this decimal, this decimal value you should add here, 0.7008. Now we can find the Q1 value. Q1, that is equal to 33.36 divided by 0.7008. So Q1, that will be, if you put this value in calculator, you can find out Q1, that is 47.6 kilowatt. That is the first answer which is asked in question. They have asked you to find out in question. Now you are going to find out the Q2 plus Q3 value. You have already find out the Q3 value. Now you have to find out the Q2 value. So to find out the Q2 value, you should use the formula which is Q2, that is equal to Q1 minus W1. So here the Q1 is 47.6 minus, and the W1 value is 33.36. Now the Q2 value is equal to 14.24 kilowatt. Now you find out the Q2 value and you know the Q3 value. Here we already found out the Q3 value. Now we found out the Q2 value. For now, what we have to find secondly is Q2 plus Q3, that is equal to Q2 value is 14.24 plus 20.36, that is equal to 34.6 kilowatt. So this is the second answer in question. They have asked you to find out, and now you find out. So okay students, so we have solved the problem. This is the second answer we have found out, which is asked in your question. They have asked you to find out. So I hope you all understand.